Evaluating limits on the calculator. And just so you know, the calculator I'll be talking about is the TI-84, although probably related calculators will operate very similarly. So suppose we have these two limits to evaluate. Limit as x approaches 0 of e to the x minus 1 over x, and limit as x goes to 0 of sine x over x. Whenever you have a combination of either trigonometric functions or exponential functions or logarithmic functions with an ordinary x, with ordinary polynomial functions, you have what's called a transcendental equation. And what that means is it transcends our mathematical ability to really do anything about it in terms of ordinary factoring. No one on earth would actually be able to factor either of these equations in order to cancel. So we have to resort to something else. And fortunately, we have this amazing piece of technology, the calculator, to help us. So here's what we're going to do. Step 1, this function right here, type it into y1. y1 equals e to the x minus 1 divided by x. You might even take a look at this function, look at the graph. And of course, as I'm describing these steps, you may want to pause the video so that you can actually do it and then catch up to me. So step 1 is to graph the function. Step 2, we're going to go to table set. And you get to table set by hitting second window on the calculator. And it doesn't matter what the start is, but here's the important thing. For the independent variable, you're going to have these two choices, auto and ask. And it may well be that auto is selected because that's the default, but what you want to do is go down and select ask. You want to be able to actually enter independent values in the table. So now when you go to the table, probably your x column is empty because normally, probably if you got to the table before, you've just seen 0, 1, 2, 3, 4 just automatically entered and then the values of the functions automatically entered. But here, since we're asking, we don't actually want to plug in integers. What we want to do is plug in numbers very close to 0 on both sides. So for example, I'm going to recommend for the x's plugging in numbers like 0.001, 1,000, 0.0001, 0.00001, and see what the y's are. And it turns out that the y values that we get are very close to 1. Also make sure to plug in on the negative side. This function is not an even or an odd function. It's not a symmetrical function. So we plug in 0.0001, negative 0.00001, and similarly we get numbers like 0.9995, 0.99995, and then 1. In other words, it looks like as we get closer and closer to 0 in either way, the y gets closer and closer to 1. So this is technological proof that this limit actually equals 1. And no matter how close we get to 0, we can't plug in 0 because of course we get 0 over 0, but no matter how close we get to 0, it seems that we're getting closer and closer to 1. So let's try this again. Go back to y equals, and now type in the second function. y1 equals sine x divided by x. We've already done the table set, so probably right now we could just go right back to the table. And in fact, if you go back to the table, all these values of x that you typed in are already conveniently there, waiting for you. And it turns out, when you plug these into sine x over x, at least the way it reads on my calculator is we just have 1s all the way down the column. Now you can move your cursor over and actually inspect those 1s, and what you'll find is that what you have is a series of 9s, and then after 5 or 6 or 7 or 8 9s, then there are a couple other digits. But in other words, what we're getting, again, is something extraordinarily close to 1. And the closer x gets to 0, the closer this output gets to 1. So we can say that this also equals 1. These are, in fact, two extremely important limits that will come up later. And this is how you evaluate limits using your calculator.